right, we've done some good work here. Now, let's do one more thing. You may have noticed that the evaluate model actually has two input ports here. And that's useful if, for whatever reason, we maybe don't document our results very well. Of course, that won't happen for you on your CRISP-DM projects. You will document those very well. But let's say we had two models that were pretty close. We had trouble determining which one's better. We can actually use the evaluate model to compare model performance side by side. So let's bring our two class techniques back in. And we'll bring in a logistic regression in. And support vector machine. All right. So what I'll do is I'm going to end up creating mirror images of my process. So I'll bring another trained model over here. Another score model over there. I'm just using Control-C and Control-V to copy and paste. And I will train with my (75% split data, and you'll see that the tool thankfully kept me from connecting to the wrong port. I'll connect my untrained model to the untrained model port. I'll connect my trained model to the trained model port for my score model. And then I will bring in my holdout data for that. And now I'll bring my second scored data set into my evaluate model. So now I can run this process and compare my two models very quickly side by side. I just realized one more thing I should do before I run this is we do not want to use region anymore. I should have done that before I copied. We want to go back to using charges, but I need to recreate that new charges field. Let's try making that threshold a little bit bigger this time. So I'll bring in the math operator. Compare greater than or equal to constant. Let's make it, let's take a look at insurance one more time. Look at that profile of charges. $16,704 for the third quartile. All right, yeah, let's use that. Or let's try and estimate our threshold, I guess, if we wanted to look for outliers. So our interquartile is 47 to 16.7, so about 12,000. So add 12,000 to Q3 and another 6,000. So 28, 34, 704. All right. So let's try that as our number and see how that works. $34,704, I believe it was. All right. And then the column we're looking for is charges. We will append that as a new column name. All right. And again, I'm going to have to submit this so I can see what that new field name will be called. Should have created a new experiment name. Well, my model is still broken, but I was able to get the apply math operation done, preview the data, see what we've got. And greater than or equal to charges equals 34,704. All right, so I'll copy that. And now we can go back to the experiment, change my train model to use that new field name. Oops. Looks like I copied a little too much. Save that. Do the same thing over here. Get rid of region. Paste my newly created math operations column in. All right, we've given it a little bit tougher job to do rather than trying to find above or below the median. We're looking at that upper threshold and see if we can find and predict items that will be above or below that. So let's run this and see how our two models perform. All right, we're at the last stage where it's gathering both those scored model data sets together. Okay, now is the moment of truth. Let's evaluate our two models. Of course, we can take a look at the scored data sets for both models. Well, it's hard to tell which model's which with the scored data sets, but with the evaluation results, it's easy. So we've got the left port and the right port. So if we look at the left port, we can see we've got an AUC of 1, high accuracy, high precision, high recall, high F1 score, our confusion matrix, our threshold slider. Right port, 0.991 accuracy, a little bit better. AUC is 0.999, a little bit worse. F1 score is better. So you've got two pretty comparable models. The curves look almost exactly the same between the two. And you can see there's basically a difference of one value in the confusion matrix. So two super close models. Again, we don't have a whole lot of data here, so I don't know that I would trust these results to generalize to a full population, but this does give you a good idea of how the technique works. Let's now take a look and see how this would work for a regression model. So I'll get rid of my classification techniques, bring in a couple regression techniques. Yeah, we'll just bring in our good old friend linear. And how about a decision forest regression over on this side? Linear, not a whole lot to do there. Decision forest. We could stick with the defaults there. Train model, we're going to go back to charges. Train, score, and evaluate. All right, let's give it a run. Come back and see how we do. Okay, let's see how our regression results look. So here we'll see the mean absolute error for model 1 and model 2. And if there's any difference, you would see that the line, left line and the right line would have different heights. But in this case, yeah, all the numbers are pretty similar. Model 1 being the left-hand port being the top row of results, the second model being the second row of results. So if we're looking at purely coefficient of determination, 0.85 versus 0.84. In this case, we would prefer linear regression over the decision forest regression. All right, so that is comparing your models using the evaluate model pill with multiple models going into it.